get started in just a moment. I just realized my YouTube chat box is... I have a checklist. I did not go through said checklist enough to catch everything. I gotta update the URL for the chat box here. Here we go. I like to get started a little early in case things don't go as planned. Say hello in the chats. We'll get going here soon. Looks like YouTube's up and Restream is going. Sorry for the background noise. I could probably turn it down. It is a little warm here in Seattle today, so I have the AC on to make sure that I can persevere through the 2 hours of streaming that we do here. Hi, David. And we're right on schedule. Okay. So hello everyone, my name is Scott. I go by Tan Newt online, and this is Deep Dive. I work on CircuitPython for Adafruit. If you don't know what they are, Adafruit is an open source hardware and software company based out of New York City. I work remotely for them out of Seattle here, and I have for like 8 years now, which is kind of wild. I work on CircuitPython, which is software that runs on a lot of the different devices that Adafruit manufactures. Here's an example of a Metro. So Metro is kind of like the shape, and then the chip here. This is a little tiny computer called a microcontroller, and it runs CircuitPython. So it's a self-contained version of Python, runs on the hardware, and it's geared towards connecting this to the outside world and making it do all sorts of stuff. If you want to program it with CircuitPython, you plug it in, it shows up as a USB drive, and you edit the files on there, and then it parses them, compiles them, runs them all on the device, which is pretty cool. So I work on CircuitPython primarily for Adafruit. I do every once in a while other stuff, but primarily it's CircuitPython. This is a deep dive where 2 p.m. Pacific here on the Adafruit channels, me or usually Tim or I will dive into what we've been working on in the past week, and it's a chance for folks to ask us questions, see what our workflows are, and just kind of hang out for about 2 hours. Housekeeping for this, or for me, is that this is my last deep dive probably for the year, or at least for a while. As folks who watch Deep Dive regularly know, I have a young child who's about to turn 6 months, and that's about the time that my partner is going back to work, and so I will be full-time dad mode until she goes to daycare, which will hopefully be in November after she turns a year. But yeah, so I will be watching her, and the current plan is that I will be part-time with Adafruit, which is basically being around and helping with what I can when I can, as I'm watching her, and then I also do have 8 weeks full leave as well. So my current plan is to take the 8 weeks full leave starting in the middle of May. Primarily because Dan will be gone for a little while, and I want to make sure that there's another person around. So starting next Thursday, I will go part-time and be kind of like when I can work, I will work. I'm trying to keep up on email and checking in with folks just to make sure that they're unblocked. And then 2 weeks or so after that, I will go into full-on paternity leave again for 8 weeks. And then when I come back, I will be part-time again. And so for the whole time I'm doing part-time, I probably won't deep dive. If there's a week that maybe Tim can't do it, maybe I'll fill in, we'll see. But basically I won't be deep diving for a while. I also probably won't be working in the depths of CircuitPython either. I'll probably be doing much smaller things. So that's the plan. I only saw one person say hello, so let me make sure my Discord's working. Anybody want to say hi in the Discord? I see David on YouTube. And how's the sound level for the AC? You can see it's a nice sunny day. Are my streaming tubes working? Is everybody gone for the day already? It is quite nice out. Hi, Mark. And DCD. DCD says, question, is BTree the only database on CircuitPython? I don't think we have BTree enabled in CircuitPython. I know that I think MicroPython has BTree, but I don't think we enable that in CircuitPython at all. I remember seeing some discussion about SQLite support, which is definitely what I would be interested in. I think that'd be cool. Yeah, I think maybe a goal, DCD says the noise isn't too bad when you were talking. I think a goal of mine when I come back, I fully intend on deep diving again once I'm back full time again. I think getting my audio turning off when I'm not talking would be a good goal for me. It's just I haven't spent the time to figure out how to do that. But I think that's pretty common of right now, just turning off the background noise. So yeah, I'm kind of in I'll worry about that in the future mode because it's going to be a little bit. I also was kind of telling myself I might upgrade my desktop computer. I might update my desktop again when I come back working full time again. I did, talking about things that aren't CircuitPython, but I did get a new laptop because I'm going to be working probably from home a lot. So I got the bigger framework, and it is bigger. This is the 16-inch framework laptop instead of the 13, and I have both, but I'd have to take the mic off to get the other one. I've been pretty happy with it so far. It is larger, so it's less portable, but it is it's more screen real estate. So when Rin is napping, my daughter, and when she's napping and I'm working from home, I'll have more screen space, which will be good. Yeah, if the docs have something like BTree, don't always trust it. You should definitely try to import it. There are weird corners of CircuitPython docs that we've just inherited from MicroPython and not turned off. So yeah, I don't make any promises about BTree for sure. If I were to put my effort somewhere, it would be in SQLite, bringing the SQLite library in and then wrapping it in the standard SQLite API would be really cool. Okay, any other questions? So I usually say deep dives are usually about 2 hours, so we have just under 2 hours of hanging out, and I'm more than happy to try to answer questions. I make no promises that I'm able to, but I'm more than happy to answer questions. Yeah, so I got a new laptop. It's for more portable working from home. Framework is really cool. I definitely like their laptops. The Framework 16, you can order it with just out the disk and without the RAM. And so because I have a very similar CPU in the smaller framework, I just took the disk and moved it, and I took all the RAM and I moved it. So my smaller laptop currently doesn't work because it doesn't have those things, but it's nice that I don't have to rebuy them. And then the webcam, actually, I was able to move over as well. So they have a V2 webcam that the Framework 16 didn't come with for some reason. And when I was putting it together, I just swapped it for the one from my 13. So that was pretty cool. And the webcam looks really good if you have a lot of light. So that was cool. Okay, so yeah, that's kind of the personal housekeeping and update. So last week we were talking about garbage collection and how it's really slow. And I don't exactly remember what we were working on, but I've done one round of review with Dan. And one thing I was doing in the original version is I was opting memory into collection, which meant there was a bunch of bugs where we were allocating memory we needed to collect that we didn't collect. And so Dan was like, Dan is the more reasonable person so he's a good compliment to me. He said, let's be safer. Let's make the current APIs default to opting into collection, and then we can put specific places where they're not marked for collection. So I did a round of that, and it's not compiling. It's not fitting anymore. There is one board that's not compiling as well. So I was looking into that. We also did meet with MicroPython. So once in a while, maybe, I don't know, every 3 months or ish, Dan and I and Jeff, when Jeff was working with us, we talk with Damien and Jim and Gus, who are kind of like core MicroPython developers. Every once in a while we talk to them, and so we talked to them on Tuesday because this collect stuff is potentially a huge boost for them as well. And one thing Damien pointed out was there's a stack that you have when you're doing GC collection that I wasn't aware of, and he said that if you run out of that stack, it still works, it just works really slowly. And so I did some testing yesterday. Oh yeah, and then I showed the tile updates frame by frame, yeah. So there's a setting for how big the stack is, and I was doing the test with the Lars.io paint that demo that John Park did, and kind of my baseline was that it was like over 200 milliseconds to do a GC collect. By setting that stack size, it dropped kind of in half because it was overflowing. So by doubling the stack size from 64 to 128, which is like how many pending blocks you have to scan, it no longer overflowed, and therefore it took like half the time. And so that was great. That got it down to like 100. And then with the selective collecting, without increasing the stack, it went down to like 20 something milliseconds. And then with that preventing the stack overflow, it went down further to like tens of milliseconds to do the collection process. So this pending PR that I have drops garbage collection times for this one example from 200 plus milliseconds down to the teens of milliseconds. So I'm really keen on getting it in before I like have less time. And so this is kind of where I've ended up today. I was doing USB debugging earlier, and it's just never fun. So I don't want to do that anymore. Hi, Jono. So I figured we'd do something a little less intense and get my PRs, the CIs on my PRs all building. So what I have here is a commit I'm about to do, and let me go to desktop. So I have to do this commit. And I can show you what it is here. So I'm dropping, so there's this enumeration buffer size. So this is a static buffer that TinyUSB has that is used in host mode to store the configuration descriptor for one of the things, but it also stores some other stuff. So it's used in the enumeration process for host devices. And somebody raised this from 256 to 512 in a PR, and it passed CI, but the CI didn't do a very good job testing it. Because I think it actually, sorry, I don't actually have another window. So this is my current one. So this PR that we just merged in, it's got a green check mark. But if we look here, it only ran a few things. It didn't build a lot of stuff. It only did the Zephyr build for some reason. And I think what it turns out is it actually breaks the S2 builds, because if you look at pull requests like this translations update, it's broken for 8 builds. And it's like, these translation changes should not have done that. So we had this PR sneak in that inadvertently broke 8 S2 builds because TinyUSB doesn't currently support dynamically allocating memory. So if you have host enabled, it's going to allocate this 512 bytes that used to be 256. And Mark says, I noticed a bunch of them broken on my PR2s. Yeah, so this is my theory, and is that this change to raise it up, so they are fixing the ability for hosts to enumerate CircuitPython devices when CDC is enabled on when two CDCs are enabled, because the descriptor is over 256 bytes long, which is good. They just doubled it, and because the PR changes a header file, it doesn't correctly there's a process in our CI, which is continuous integration, that looks at the changed files and tries to guess what boards should be built, and it's just doing the wrong thing. It's not correctly rebuilding everything that includes this header, which is why it passed CI and got merged in, but in fact it's actually breaking CI. Will you be able to identify why the CI didn't catch the error? We could get into that if you want. I'm actually kind of don't really care. We have this, so if you look at the CI, I'll go into it a little bit. So there's this scheduler job, and it runs a few things, but it runs this set matrix thing. So there's this script we call CI set matrix, and it shows you what files changed, and then it has heuristics to figure out which boards to build. And it's not perfect. We know it's not perfect, but it really saves the planet to be kind of imprecise about it. But basically, we have so many boards. This is trying to be conservative about what boards to run, and it's just not always right, and it's just never it's really hard to be precise about it. For example, this is a header file, and header files aren't referred to directly in makefiles. It's the source files that refer to header files, and so figuring out exactly which source files refer to this is this one is used anytime TinyUSB is used, but I know that, but it's hard to determine that programmatically. So is it bad that our build is broken without knowing it's broken? Yes, but I'd rather be what is this, a false positive, false negative, whatever. I'd rather not build too much than build too much, I guess is what I'm saying. So we figured it out. We haven't had any other changes because everything else is broken. And now I have a fix for it. So not only am I shrinking this size down to about what we actually need, but because all of the TinyUSB buffers we're overflowing RAM. We're not overflowing flash, which is doesn't happen all the time. But then TinyUSB has a bunch of static buffers because it doesn't do dynamic memory allocation. So I'm actually also adding this thing to shrink static device buffers for TinyUSB, just to give us even more headroom on S2s. So you can see here that on so this is an espressif. The CDC receive and transmit buffers are 1024. I'm dropping them down to 128 each. And I'm reducing the mass storage buffer size as well. And that saves statically allocated RAM. I did a test build already, and it dropped from 99% full to 95% full. So that should give us enough headroom, because I think I'm going to need it for my change too. So we're going to say reduce USB static buffers for SB32 S2. this frees up or RAM other things. Hi David. Just in, or started overflowing. So I'm not going to say it fixes this issue, but I'm going to reference an issue. Started overflowing. So by putting it in here, it will reference it, I think. So I committed it, and now I'm going to push it, and I'm going to try to get it reviewed so that maybe Mark will review it for me. So this should tickle more of the CI. Okay, I pushed it, and I'll make a PR, and I expect it to pass. It's going to be kind of annoying. Because if there's pending PRs that are suffering from this, they're going to have to merge in the newer stuff. Hi, Beata. So now what I'll probably do is I want to fix my selective collect. Thanks, Mark. I'm going to take a look. Yeah, you can see a lot of these are broken. Probably anything that caused all the S2s to build will have this bug, or will have broken. So, but my selective collect has 39 breaking things, which is more than the 8 that like we saw with translation. But we can see here that it's a lot of S2s. I think this is an ESP32, but it's mostly S2s. So I'm definitely like, that's why it was a little more like, I'm gonna make even more room. So we'll take a peek here and see if it's also filling up RAM. Yeah, 344. So that should be good. We can test it here. So I've got this open. So let's now switch to GC selective collect. And I'm just going to git merge in this host enum buffer. Interesting. Okay, I got some other stuff too. And then I'm going to look at Lowland S2 Mini. Let's see how big it is. They don't, so DCD asks, do the other broken CI builds automatically get restarted, or do they wait till they merge in your PR? I think they have to wait till they merge it in. I'm not super clear on if you retry it through the interface, whether it will retry with a newer version of main once it's merged in. I'm not actually sure. Maybe somebody else watching knows. And then I notice also there's one failure on IMX that I've got to fix as well. So I'm going to have to fix that too. Let's just go here. I don't know why it's only TT41 that's broken, but fixed it. Yeah, Mark says, I can try with my PR once it's merged in. I think I have to fetch and then merge it in to your branch too, yeah. Yeah, so this is, I really like Control P, both Sublime Text and VS Code. This is a variant of VS Code, but they both do it. It needs to be const. Apparently CanIO is only enabled on TT41. Okay. And then this is the Lowland one. And the Lowland one says it has 95% used. These numbers I don't think are right. Like this says there's 60 bytes free in internal SRAM1, which this says region size of IRAM and DRAM0 is 152K. So I don't know why that is. It's possible it's wrong. What is esp-idf S2 RAM? Maybe there's a problem in our script or something. Maybe we could double check that too. I was playing with readelf the other day. It can extract useful segment sizes. Yeah, I've played around with that some too. Okay, so 320K of on-chip SRAM. So why are we being limited to 152? Like, why don't we see 320 there? Like, it's not 320 here. IRAM0 2 seg. Like, that's a very high number. DROM seg. I don't know how these are, where these are coming from. Yeah, the linker scripts. So what linker script are we doing? Let's take a look. I guess we can find the length is this minus this plus that plus that. Which is what? Address mapping structure. embedded memory is 4,000 onwards. If we look at this, it says we're 4,002 onwards, and our length is this, between this and this. I wonder if it's splitting it somehow. Can we pull up? Let's pull up that file. Expressive Lowland, and then it's idf system LD. idf system LD memory. Okay. Even though the segment name is IRAM, it's actually mapped to flash. Great. I see. All of these values assume the flash cache is on and have the blocks this uses subtracted from the length of the various regions. The data access port allows DRAM and DROM regions to map to the same IRAM, IROM regions, and allow byte-wise access. So, interesting. How much is that? $128K. Yeah. So if we have 320, yeah, 192, but we're also subtracting out, what, the 4s? 16K? 160. And we have a missing 8 there. I don't think so. Was that to initialize the RAM on startup? I don't see it. So what is this? $155, $648. $188. So the memory region it's doing is 184. It's doing 184, and then it's subtracting out 2. Flash cache MAU's constraint that pointer address has to be mod 64K. So not initialized, yeah. So I don't know why it's linker script generator. All these values assume the flash cache is on. External flash. Hi, Relic. I pushed that PR, right? So the CI can run. That's kind of wild, though, that it's like 320K and then it gets all of... So here we go. All right, we're cruising. 17 queued. So it looks like it's not building everything. If we go to the scheduler and we'll see what it built. It's doing ESPs, oh, and SAMDs. Microbits, Nordic. I don't think it's done queuing everything up. Waiting for pending jobs. Yeah, I'm glad I got it started. This is a different build. That's okay, it's going. That's what's important. Thank you for the review, Mark. So we think we're doing 128K towards the flash cache. And then we have these two other 16K regions which get reduced. I wonder if we can find the place that this is. This linker script is passed through the C preprocessor to include configuration options. Use preprocessor features sparingly. Let's find this file. Let's see what the original says. And let's go to 5.3 because we're not quite on 5.4. Okay, so here's the .in file. So second stage bootloader IRAM loader segment starts at the end of block 13. Which is reclaimed after the boot, after app boots. IRAM start, DRAM start. ID, RAM size. Here, instruction cache size and data cache size. Oh, so it's two caches. Hmm. 19 and 21. API guides have performance. Interesting. Instruction cache size. 19. This is not quite the same. Why is that? I think we're on 5.3.2 is what it said, right? Ah, here we go. If instruction cache is 8K, then we do this, otherwise it's 16. Data cache. 16. I don't know why IRAM start as that, because ID RAM size is the RAM end minus DRAM org. Why is IRAM start shifted like that? Does DRAM go first? What? That's so weird. Technical reference. 320K internal DMA address space. This shows it at 4,000 and up. Addresses below 4,000 are served using the data bus. Addresses in the range are serviced using the instruction bus. So why? I like this. This has 456K of internal memory, and it's like, you don't tell us that. Okay, here we go. Internal memory, 4 segments. This is what, oh, that could be why. Here we go. These two are internal ROM, internal SRAM1 and 2 is 32 plus 288. Is 320, but if we go back to the linker script, the linker script is limiting it to a smaller number, right? It's limiting it to these bounds, DE to FB. So if we go back to our data sheet, it's almost done. I don't really believe you. So this is weird. Why? FFB DRAM start. And then 3FFDE. Second stage bootloader IRAM loader segment starts at the end of block 13, which is reclaimed after the app boots. I see. So we're able to use the rest dynamically, but we can't use it statically, I think is what it is. 3FFDE, which makes sense to me. 3FFDE. Okay, so that just means that the second stage bootloader, the thing that's going to load that stuff in, heap port memory layout. I'm surprised there's no. This is for a different chip. Yeah, so I suspect that's what it is. Like, we're running out of the SRAM that the second stage bootloader will load for us. And then we can use it dynamically, which is why you can still, like, do any sort of dynamic allocations. So shrinking these tiny USB buffers will be fine because they don't really impact performance as far as I understand. How is it? Yes. Neradoc has a good point. Will downsizing the USB CDC buffer make this thing happen on the S2? Like it does on the Sandy20, which also uses 128. Yes, it will. So the way Control-C is handled weird. I don't know if Neradoc's watching. Probably not. We could make it longer. See, it says that it's successful here, but this one says it's still going. And 245 is a weird number. Oh no, it's green here. What did it build and what did it not build? It built esp-idf. It only built esp-idf. Yeah, see, so it built esp-idf and Zephyr. So it didn't correctly build any of the other tiny USB configs, but because I'm reducing the number, I'm not too worried about it. That will happen just like on 10D. Yeah. Yanni says Zephyr and esp-idf were built. I'm not sure how we're deciding to build Zephyr. It might just always be always. I forget that the logic I think is different. I'm just going to merge this in because it's going to unblock us. If we want to raise this buffer back a little bit, that's fine with me. But I want to merge it so that we can start fixing builds. Which is also why I feel okay doing it. We'll see if Weblate... Yeah, see, so Weblate automatically does the merge. And it should pass now. So let's go back and now that it's merged, thank you, Mark, for the review. Let's do a different merge. Let's see what happens when we merge into this. Merge made by the ORT strategy. So now we can see we have this merge and the merge of the other thing, but I think those merges don't. I don't know. Oh, you know what? I also need to fix IMX. So I have that. Before I push, let me do fix teensy. All right, Mark's gonna push it to their PR as well. We might as well just hang out and do something else because the CI is gonna be running for a while. Doing all these tests for us. So that's the answer, is that the RAM that we have that the second stage bootloader will load for us. That's really interesting because most of our ARM stuff has code right at the beginning that loads itself. Whereas like on on Express if apparently the second stage bootloader is doing all of this RAM initialization. Yeah, which is really interesting. All right, I think we've root caused that. GC selective collect will hopefully be green again. The translation builds are going. This build will going. Except I didn't push. And I don't need to force release. Ty says, where would you find that kind of info that the second stage bootloader nicks block 13 after the app boot? Or whatever the exact details was, and hi. Just like I showed, like, I don't know, like the second stage bootloader didn't even, like the second stage bootloader is in here, but like it doesn't even refer to that address. So it might be like the second stage bootloader size, like the top end of RAM minus however much it needs. Is how it's computing that number. We can dig a little bit more. So let's, I think the second stage bootloader is this subproject main linker script S2 bootloader IRAM SRAM part of block 12 and 13. Make sure the bootloader can load into main memory without overwriting itself. SRAM part of block 12. So these are in the 4 ROM static buffer starts at the end of this region, which is reclaimed after the app runs. ROM static buffer starts at the end of this region. I don't know what that means. I don't like linker scripts. If you haven't seen me rant about linking and linker scripts, then I'm sure there's a deep dive where I've talked about it. But yeah, linker scripts are the worst. They make everything way more difficult to reason about. Oh, I don't care about derailing. I'm not really doing much now because I'm hoping that all of the selective collects will pass because it looks like they're all... I'd rather learn linker script language than CMake language. Well, I'll tell you, the problem with linker scripts is that they're different between compilers and linkers. There's no, like, they call the one that comes with GCC BFD, and there's no formal spec for it. And the reason I know this is because I listened to the people working on LLD, which is the Clang linker, and they say, you just have to test it. There's no, like, thing. I don't know. I don't like CMake either, but that's why I did Python. Involving linker scripts in Python at some point. I think my vision for how to get rid of linker scripts is to leave it up to the compiler and the linker. So what you would just tell them is what you would tell them is just like, here's the memory regions that you need to fit into, and here's properties of it. Like the fact that here they're like straight up like mapping sections and stuff into it is just like, And then you have keeps and init arrays. Like the init array stuff is really, really hard to debug because init arrays are like, you get this symbol and then they're just function pointers or something that you call them all. It's just insane. It's insane to me. It's really hard to debug when you hit bugs like you forgot to call on init because it didn't get linked in. Like the idea that like you don't have a missing symbol because like it's just terrible. Terrible, terrible, terrible. I do not like linker scripts, and I've tried them. Like all this stuff, like, oh my goodness. Like, why? Why do you have to worry about this? Yeah, the init arrays are often tied to CRT0 startup code. Yes, and they're the worst because they don't generate missing symbols. It's bad. It's just bad. Like, don't do it. Don't rely on it. Like, as somebody who's hacked rebuilding some of the expressive stuff, like the bugs we get are where the CMake for the IDF says, hey, you have to say this other random symbol. You have to say this other random symbol is like undefined so that it like looks in the right place to include it. It's just real bad. Why not just generate linker scripts? Yeah, and Pico SDK started doing this like registration system, which is the same thing, which is you put certain things in a certain region of RAM and then you just iterate it over an array. And it's like the compiler doesn't know this array. It's a linker thing. You don't need linker scripts. You could have the linker just know where, like, all you need to know is where RAM is and what properties it is. Like, can you execute from it? But then you can do smarter things like saying, like, it takes 3 cycles to access this, or like, what is the latency for these different memories? And then you can do really cool things like the things that you think you're going to run all the time go into fast memory. All these sorts of things. I'm very interested in this, and I want to like take a stab at getting updating the linker things to do this too. But yeah, the registration stuff with using linker scripts to do that thing, I constantly have bugs with that. And to me, the reason we have difficult bugs around that is because they are assuming a tight coupling between the build system and the source code itself. Like, you don't get compile errors when you're missing a symbol. Like, if your registration is missing a symbol, you don't get a compile error out of it. So it can look like you're compiling, and then when you run it, it fails. Right. We had to include a .o file on the link command to get the undefined reference to pull in. Yeah. The other place I find it is that if that .o that you included explicitly is included in a .a, which is an archive, like the O's from the archive are only included if like they have a symbol or something. It's just terrible. So I really want to like experiment with both, not only the linker, but also the compiler having more knowledge about memory layout. Also because we're working in embedded systems and there's no reason we can't do link time optimization of like merging functions and stuff like that. And that's kind of where you blur the boundary between like what the compiler should be doing and what the linker should be doing. Is when it comes to inlining and optimization like that. Oh, anyway, we got an hour left. My brain's tired. I was doing USB, which is why my brain's tired. That and I have young children. Oh, interesting. So here, it was actually quite smart. So the translation, when it merged it in, it didn't rebuild everything. It only rebuilt the ones that failed, which is not perfectly accurate because the thing you merged in could have broken something else. but it means it completed fast. Yeah, that script. It's nice, but it's not perfect. I'll merge it in anyway. So if we look at the scheduler again, let's see what it says. So if we go to set matrix, and we can see that it's just building 1, 2, 3, 4, 5, 6, 7, 8 boards. So it took in, there was no changed files, which is correct if you're worried about the PR only. And then last failed jobs has these 8, which is fine. So it's, like I said, the set matrix thing is not perfect, the scheduler thing is not perfect, but in this case it actually like saved us from rebuilding everything. It wasn't correct, but it saved us from rebuilding a lot. Let's see what it's going to do for this build. Sounds like a patchwork of band-aids over duct tape over. Yeah, I mean, that's kind of my opinion about linker scripts, but it really does beg the question of like, how do you adapt a program for a certain memory layout? And it doesn't get a lot of love because it's quite unique to embedded. Like, you don't, like linker scripts aren't used for desktop apps. Because like, CPUs that run mixed loads and like operating systems and things, like they have a big memory hierarchy, but it's basically hidden, where it's like, you know, 3 levels of caches and then you go out to DDR RAM or whatever, right? Like, and whenever you do that, you're doing that in like 4K pages or whatever, right? Like, and then you're also in a virtual address space, right? So like the memory address space that you have for any running app in a Linux app is just, you know, however many 64 bits of address space, and you can talk to whatever. So like linker scripts are pretty unique in that they're used when you're not running in a virtual memory space, or it's like quite tightly coupled to the actual memory that you're running on, which is microcontroller land. Which is why I kind of think of like the work that I want to do is like, I'm going to make a linker for embedded. Like, I'm not going to have this, like, it's not necessarily that I need to upstream it, because I'm not trying to make a linker for Linux apps. I'm trying to make a linker that's good for microcontrollers. And like, yeah, this is just a bugbear of mine. Like, Espressif can't do link time optimization because it's like really hard, and Pico SDK has the same problem. It's really hard to manage code that you want to live where it can you manage code that you want to execute when some of your memory spaces are disabled. So for example, if you're writing Flash, you can't read from it. And so, but Flash is where most of the code runs from. It's just, so there's like all these terrible tricks. If you looked in Pico SDK where it's like not in Flash function, and it's like not in Flash, no inline function, because like if you allow it to be inlined, the thing that it was inlined into is not marked as not being in Flash, and it's just like, ah. So, yeah. This is one project that I'm looking forward to getting back to, with really trying to get like an LLM agent alongside me to really help, hopefully help finish it. There's a couple ideas that I've had for a long time that are like super amorphous that I want to experiment with as well, and I think an LLM could be a really good way of getting over the blank page hump, especially because some of these other ideas that aren't CircuitPython related are ones that will likely use technology that I'm not super familiar with. And so when I read stories about like using LLMs to code, they say like it's really good for that sort of thing. An example, I used Claude Code today. I was testing the latest USB stuff, and there was a change in TinyUSB to one API, and I said, instead of me doing the research about how it had changed, I said, update this. Like, this thing changed, update this. And Claude Code got it I had to restart it once, but then I gave it a prompt and it did it, which was pretty wild. So if you're a programmer or you're getting into programming and you haven't tried Claude Code, it's really interesting. I said I had to restart it once, and the way I tweaked my prompt the second time is I said, build it to begin with, because then that gave it the same context as like the compile errors that I was facing, and that gives it a lot of like more unique things to search for. It's really interesting. If you're not playing around with that stuff and you're in the software world, I suggest you do, because when I've used an LLM to code, it's usually when I'm at to the point where I need to do a lot, right? Like I have a lot of changes I need to make. They're in a lot of files. That's when I found the greatest benefit, and because I'm not having to do all that manually, but what it leaves me to do is still all of the programming stuff, like, oh, don't do it this way, do it that way, or debug this, or do that. But I'm not having to do all the typing and switching to files and all that stuff, which I think is really cool. Okay, so it looks like my CR, or my PR, is also just building everything that failed. Plus IMX. Yeah, so teensy as well. Although I would expect to build all IMXs, but maybe it's smart enough to know. I don't know. It may not be right. I probably should have built more than that, but oh well. If it becomes too much of a problem, we'll fix it. Okay, so we have an hour. What do folks want me to work on? One thing I was thinking about, and maybe this is a good hour-long project, is we actually want to have a code editor on the Fruit Jam. And there is one, but it doesn't work that great, and I want to change the way it works a little bit to use its own terminal. Maybe that's a good use of an hour. I fried my fruit jam. I didn't say that. There's 2 revisions, and the second revision one I have doesn't work anymore. This one doesn't work. The DAC gets really hot and it doesn't start up because I was trying to get the speaker working, and then I like did something and then it just started getting hot and it doesn't work anymore. Oh, you know what? There is a bug. I see Cooper talking. There is also a bug where audio playback stops working if you do it. Like I think I fixed audio playback so it wouldn't play back random memory, but I think it doesn't. I don't think it always restarts correctly. So we could fix that bug too. I should probably do that next week too. I don't know. So I do have I have my older Rev A fruit jam in my backpack that I have to get, but it still works. It's just not as nice as the Rev Bs. How much current is your fruit jam drawing when it gets hot? Probably doesn't matter. It's broken sad. I haven't looked. Have I considered swapping it? I thought about it, but I don't have soldering workstation here. I would have to go to the makerspace, and I also have a backup fruit jam that I could use. It's just not closer to what will be final, but the hardware's not final still either. But yeah, I think it's just the DAC, because if it's cool, it like blinks for a little while and then yeah. I thought I was going crazy. Audio would just stop after 10 seconds. Figured something was wrong in my code. Did you have a soft restart or not? I should probably fix that bug. The code editor, this is kind of interesting thinking about, like, especially my time's going to be quite limited. The code editor thing is something somebody else could do because it's Python level. The, like, fixing the changes I made to audio DMA, other people could fix too, but it's more difficult. Like, the number of people that have fixed that is smaller than the number of people that can do, like, the code editor stuff. So that's probably no soft reset, and it's still stopped. Snacks and hydrate. I do have some vitamins I can have. Okay, I think I should poke around at this problem. The problem, well, the reason I haven't poked around it yet is because I saw it when I was doing the speaker stuff, and the speaker stuff was like all sorts of crazy stuff's happening because I'm powering a speaker. And so I didn't trust it enough to look at it then. But I'm going to grab my other fruit jam and get it set up to test it out. So I'll just unplug and do that, because that's I think more of a me thing than the editor stuff. All right. I'm ready for the weekend. Pretty nice out. Okay, so here's my Rev A fruit jam. I know people are really excited. I'm excited about this board. It's very cool. It's got HDMI audio out, headphone audio output, USB-C. This has an SD card adapter, but I think it's replaced on the newer Rev with an ESP32C6 for Wi-Fi connectivity instead. It's got a USB hub chip, and then it's got 2 host ports. And then an RP2350 with PSRAM, which is why I was looking at the GC Select stuff. Okay, I'm gonna unplug this other stuff and find my setup here. So I think this is the HDMI plug, and I'm very happy I fixed this audio bug because it was still quite noisy. All right. My desk is getting unruly again. Every once in a while I've got to clean it. Still relatively clean too. Okay, so I'm going to plug it in and see what is playing. Which bit of the other fruit jam smoked? I think the DAC. Let's see, is overhead? Oh, look at that. Can you hear it too? You could probably actually hear it. Could you hear the chimes? I should put my headphones on and I'll be able to monitor it then. Although if my TV's on, turn my TV on, I'll be able to hear it then too. Did you hear the fruit jam sounds? I see a yep. Maybe I should be able to hear it now, so let me hit restart. I usually listen through the TV. So Foamy Guy did this animation. Well, he didn't design the animation, he implemented it. Sounded nice, good level. You're gonna hear it a lot, because I'm gonna hit it again and check my levels. Tell me if it's weird if you can hear it through my mic. Yeah, it sounds good. There wasn't like a click at all. which is good. I don't even know exactly what version I'm running on the board here. Didn't see any artifacts on this side of YouTube. Okay, so hopefully I can hear it through the TV, but you can't really, because my mic is like on my lapel. Let's see. Hi, Osama. I can add that there. Add the chats back. And I think what I want to do is I'll go to the desktop with the overhead. And I want to make the boot up animation the thing that runs continuously, because I think that's how I can tickle the bug. So I'm going to go into CircuitPy, and I already have this boot animation. That's an old version. I'm actually just going to delete it and move this over. Oh, did I? Nope, it's still going. I'm going to rename this code launcher 2, and then I'm going to duplicate this and rename it to CodePy. And then once it syncs, we should see on the screen that it will run the boot animation every time CodePy runs. So let me know if you want me to turn it down. Is the boot sound a WAV file in ROM, or is it generated? It is a WAV file on the CircuitPy drive at like 11K sample rate. All right. I did not hear it. It didn't play that time, did it? Oh, you didn't see any artifacts on this side of YouTube. We could capture it and see. This is a slightly different thing, and in fact, I think it might actually have crashed because my USB. No. Oh, you know what? If the audio fails to play back, it never stops. The animation will keep, yeah, it does exactly what it did. So we won't hear it now. It thinks it starts up, but it never finishes because something happens, it's broken. This is the bug that I'm talking about. So let's start to debug it. The other thing I'm going to do is, this is my setup. So I compile up in the top here. The left-hand side is the USB connection to CircuitPython. The right-hand side is usually debugging that happens via uart. So I've got a USB to uart converter here that I'm going to plug in to my tangle of wires. And you should see it connect. So let me, I can remember which pins I even do it on, although I don't know the order. I never remember the order. Okay, so now we're connected. So now we see it come up. So this is how I've tickled this bug before, but Cooper, I think like you're saying, I think it's a race condition around like enabling and disabling DMA channels. And we'll get into it a little bit. Let me first get the console working. So one thing I found that I really like is I'm in GC Selective Collect now, and this is Sublime Merge, and it can show me like my latest Git history. But one thing, it also shows stashes. So here's like debugging I did for GC UART, and oh, here's the thing I've been using a lot, which is turning on the console UART. So one thing you could do here that I was pretty excited about is you could click this and hit cherry pick hunk, and that will copy the change into my current branch, which is nice. So that will enable console UART on 4 and 5. In fact, I can see 4 is yellow, and yellow is going into RX, so I think that's right. I got it right. This is the change that the GC stack change that made it go quicker. And then a different thing. But then debug frame rate has some debugging I already added to audio DMA. So I'm actually just gonna I'm doing the same thing. I'm gonna just try to cherry pick all the changes from the file, which it seems like it worked. And I changed this, but I don't think I actually want to change that. I thought it was some interaction between, I thought it was some PIO interaction. That's why you see a lot of PIO prints, but it may not be. This one's super handy to just not safe mode if you hard fault. So I will cherry pick that. And this is another weird thing. So now I can go here and I can say, oh, you know what? I don't want this bit. And I can say discard lines. And now that won't be a change. Okay, so I'm going to go to Raspberry Pi. I'm going to make Adafruit Fruit Jam debug. I'm going to clean because I want to start. I like merge things and done things that I don't trust, like Make's ability to figure out what it needs to change. So I just start clean and fresh. And we're building it, and we'll load it in just a moment when it's done. Race condition on audio being lost gave me flashbacks. Right, so there are 2 buffers. So I'm just manually loading udisk control. And I don't want to do the other stuff. I just want to do this. I have gotten bitten by having a very similar command that loads the Metro image, and loading the Metro image onto my Fruit Jam just doesn't work, and it confounds me every time. So that's a heads up. Okay, so hopefully the chime's not too loud. Let me know if it is. I can turn it down. But it should come up here as boot.py, and we can see debug prints. It still sounds good even though we're doing debug prints. And now it'll stop, and now we'll go to code.py. Our USB is starting up. It worked again. And then let's just see if it works again. It didn't work this time. So the animation's going, but the audio's not. And now we have some debugging. So we have channels 3 and 4, which is interesting. The control masks are here, and they are different. Channels to load mask is 8. And then at the end, it is 0, which is in theory that we didn't miss one. It's interesting those channels 3 and 4 because I suspect that, I don't know if we have that much history. Oh, it's channels 3 and 4 here when it did work. Interesting. I feel like it used to be 1 and 2. It was 3 and 4 here as well. Oh, you know what? That's because 1 and 2 are now being used for HDMI display. So when I was debugging this last, I didn't have the display plugged in. Okay, so same thing's happening with different different channels, and it looks like it looks fine. So like these control registers look okay. 208.15 and 206.15. And then let's go, yeah, 208.15 and 206.15. One thing I want to look at is, oh, maybe I should describe how this works. So the way the audio playback works is that there's two buffers that are kind of like the last buffers that go out to the PIO I2S. This is definitely happening when doing normal audio work as well without HDMI. Yeah, I saw it without HDMI too. But that just explains why the DMA channels are different numbers. So there's two buffers, and you fill one, and then it's, yeah, they go back and forth. So when one is done, you fill it with more audio, and then while the other one's playing, and then you switch back and forth to which one you're filling. And so there's two DMA channels, one for each buffer, and they trigger the other one to go when they're finished. So the one finishes, and then the other runs, and when the other one finishes, it triggers the previous one. What was happening, the original bug that I fixed was that was happening even if the filling never happened. And so if the second one triggers the first one again, but it hasn't been filled, it starts at the end of the buffer and then reads off into random memory. So that's why you were getting all this crackling. It was really really bad. Like you would ask me to turn it down on the stream if that was still happening, but it's not, which is good. The way that I fixed that is that when we get the interrupt to say a buffer is done, we disable that DMA so that even if the second buffer triggers the first one, it doesn't actually do anything. But that means that you need to recover if you've missed a buffer, which I'm trying to do, but may not be. There may be some like intricacies in the order that that's happening. How do I want to debug this is a separate question. So in my mind, I have two options. One, can I do uart printf debugging? I can do that from interrupts. It's not super wise because it takes time, and it can actually, like, you can insert characters into other characters. The other thing that I could do that makes this stuff easier to understand is actually doing pin toggling to figure out like the timing between different parts of the code. So like I'm filling a buffer, but an interrupt happens, and like things like don't quite synchronize or something. So let me print first and see what happens, and then we can move to the Salier if we need to. We've got 30 minutes. This is a small tractable bug that I also don't think, like, talking about the LLM stuff, like, I don't need the LLM's help here because I'm not producing a lot of stuff. I'm just debugging, and I'm doing a lot of things that LLMs can't currently do, which is load to firmware and see its output, which you could potentially actually make available to it too. But that's a whole nother thing. Okay, so we're not doing IMX anymore. We are in audio DMA land for Raspberry Pi. And in fact, let's close others. And we want audio DMA. And I just want to see the disable. DMA stop. All right. So this says if MP state port playing is not null for a given channel, then we disable it. The other thing we could do is figure out how to get ourselves to the point where like something's printing out the status of that register. Let's just start here. See what it does. And here I'm gonna, since we're printing out so much, I like this. If I stop TO, which is kind of counter to what the way TO is nice, but if you clear it, now like my scroll history is just this run with this firmware version, which is nice because it generates a lot of output. So, but now I could like go to the start pretty easily. It's just turning it off. So it worked. Record all channels whose DMA has completed. They need loading. So it worked the second time. And now we're going to Control D again. And it worked. I wonder if we interrupt it. Now it broke. Interesting. So I did break it. Disable channel 3. So here, when I talk about it, so here's a channel 4. There's no disable word, but I suspect that it is that still. Which is interesting. So this, maybe not. Maybe it's another channel print. It's probably another channel print. Yeah. Never mind. So we get one interrupt. It disables channel 3. But it looks like channel 4 never runs. Because I don't hear any audio. I don't hear any audio. There's a busy bit. Where do we see the DMA busy bit? Because that would be interesting to print out. RP2350. Oh, I switched to a tab you can't see. DMA, okay. Configuring a channel. Data request, triggering channels, configuring channels, list of registers. Let's look at the list of registers. Each channel has its control. And then when we get to the end of the channels, I think we have, it might be interesting to look at interrupt status in case our interrupt status got messed up. It could be that. Interrupt enables could be wrong. Like, maybe it did run the second DMA buffer, but the interrupt wasn't on somehow. Maybe it got, maybe there's a race condition around enabling and disabling interrupts. That could actually be true. We don't use the pacing timer. Interrupt enables. Int E0. We could also look FIFO levels. Trigger channels. Abort and in progress transfer. Writing one. The bit will remain high until any in-flight transfers have been flushed through the address and data FIFOs. Must be pulled until it returns all zeros. It's possible it's that. Security config, I don't care about. MPU, I don't care about. Debug stuff, I don't really care about. Although I should check. I assume because it works prior that it does work. I wonder if it's an interrupt thing. Like, I wonder if there's some other code that's like doing manipulation of the interrupts that's, I don't know. Maybe what we should do is, instead of printing disabling the channel, we do it. ISR %08x interrupt 0, and you know what? Let's do, we'll call it E. Okay, so let's print our enables on the interrupt and make sure that those are right. I wonder what it is. I'm intrigued. I find it worked really well when I'm like, I wonder. When I'm curious about things, I'm very, okay, I'm gonna do that, and then while I'm in that, I'm gonna clear it. I kind of doubt it's this. It could be like some other thing around the DMA. Like, a lot of this machinery is working when it works, which is the frustrating part of all of this. Now it works again. The other thing to check on a bug like this is the errata of a chip. Will it work a third time? Yes, but if I stop it, I interrupted it, it should have, you can see filled count 2, channels to load mask. Now if I hit it again, it doesn't work anymore. The ISR works once. Both ISRs are enabled. When we we call audio DMA stop, and then we are restarting DMA, even though we should be stopping, which seems bad. Let's take a look at that. Channels to load mask. DMA callback function. Field count equals 2. I think we have. So pausing is doing enabling. So if we are paused, we don't want to re-enable. So I think we actually need some new state to prevent Playing in progress. In progress. Okay, so I don't think that includes paused. So I think we want to do bool paused. And then because I think stop will pause first. If filled count and not DMA paused. Get paused. Nope. Why would you want to do that? Pause all. This is where I find windsurf to be quite good. Like this, the suggestions that it's doing here, like skip down here and add this thing, is like not something that GitHub Copilot was doing for me in Sublime Text. It might do it in VS Code, but it's certainly not doing it here. So when we do stop, we add the channels to the channel mask. We disable the interrupt. We run any remaining audio tests because we remove ourselves from playing audio. We remove ourselves from playing audio. Down here, we abort. Hold on to our buffers. So we lose our interrupts, but we could get restarted again. This doesn't make sense. We don't want to do this. I think pause is supposed to only be true if we're playing. I think that's right. I think that's right. Cooper, when you were running into this issue, were you playing and pausing things? Or were you just letting it run? Oh. Okay, it's playing. Now it's going to play again. I'm going to interrupt it. Ooh. Stop. It still said restart. It still did the restart. And now it didn't work again. Just letting it run. Well, that might be a different bug. Channels to load mask 24. DMA paused. Am I in the right place? I am. Field count. Code done running. We call stop. We get the interrupts. We get another interrupts. We get for one buffer, and then the other buffer. And then we get the other buffer again. Channels to load the mask is both channels. And therefore we restart DMA. What the heck? I thought I fixed that by, let's see, dnet does. We're not doing dnet. Are we? It's going pretty far before it. What is calling stop? Init, dnet. Paused is true. So run background task is where the buffer filling should be being run. Unless it's being run. No, that should be right. Nah, I don't want that. Pausing. So if I set DMA pause to true, and then the callback function is getting the audio DMA out of that. It's looking at channels to load, which it's also printing out. And then field count is equal to 2, which is true. And it's not paused, but it should be paused. Is it somehow still running? Let's add another print. Seems like printing is doing okay. So let's do stop to print. Figure out like if we're getting if the background task is running all the way at the point after we're done. That's bad. Maybe we need to like remove ourselves from channels to load. Just letting it run. I wonder if this will fix it for you. Control C. So it is between audio DMA stop and pause. Oh, you know what this could be? This could be, I think that console uart printf runs background tasks. Which we could fix by doing pause right at the start before we're printing stuff out. Because I think because it's outputting the uart, there's times where it has to wait. So I think that might be it. Which is not actually a problem if run background tasks is kind of like async IO, where like other stuff only runs when you explicitly say it can. And at this point, you're calling this time like it would be await like console uart printf in that world. All right, let's see. I don't know why it stopped working for you, Cooper. I think there is a race condition about filling a buffer. So now it broke. So it still broke. Audio DMA stop is called twice. Field count is 1. Oh, I guess stopped is calling run background tasks as well. It didn't restart it, but it's still not working. We're enabling the right channels. This channel to load mask is if we are filling the buffer. Audio DMA stop being called once per channel. I'm not actually sure why. I'm not sure what is calling audio DMA stop. Presumably it's the finalizer of I2S out. But yeah, I'm not actually sure why it's called twice. Trigger source looks right. Maybe what I do is where I'm printing this stuff out, I should print all of the... Yeah, these are DMA. Channel 3 and 4 are DMA channels for the ping pong buffers back and forth. Field count 1, channels to load mask is 0 still. We didn't get another ISR, we would have seen that come in. So it's like the trigger. The enable bit is this last bit here that makes it a 5, I think. So, what's another reason that Let's just print them out. Load next block 0 and load next block 1. We're not in single buffer mode. We enable both interrupts and IRQ 0. We start channel 0. Channel 1 is waiting to be triggered by channel 0. Since I'm having an okay time printing in the ISR, let's do that. This is where it can be helpful. If I put a 0 there, I don't know what it's suggesting. Oh. Do you want this percent P? There we go. So now I'm printing out the control registers for each one, and then there is a busy bit. It's also that the abort could not be cleared. Transaction count, read address. Trans count is probably suspect. And then it automatically expanded it out for me, which is nice. This is going to slow us down further. And I can't do it there. Let me just hard code it. Here I will just do 3. And so I'm hitting Control D to just do the multi-cursor select. And any final questions? We're just about out of time. I will have to pick this up on Monday. Just fine. Any final questions? Before, you can always find me on Discord. When I'm on my 8 weeks paternity leave, I will try not to be engaged on Discord, but there's other folks that can help during that time. You can join the Discord server by going to adafru.it/discord. I'm loading this last one up, see what we see. If you want to support me, you could go to adafruit.com, purchase hardware there. Phil and Lamore, Lamore owns Adafruit, and they've been very generous supporting me through having these 2 kids of mine. So they're a great company to support. And it's still going. Did it stop? Did I slow it down that I broke it? Kind of looks like it. Yeah, because the audio didn't play back, did it? Transaction count. Thinking about this. Channel load mask 16. This is a maybe I just like these prints make it more obvious that it happens. But it is a case where, in this case, I think what happened is that we re-enabled buffer 0, the channel 3, too late. So by the time, I was worried about this, by the time it goes, we have to enable it before the second buffer finishes. So we really need to do some other sort of check. We have to say, like, if both channels aren't busy, is some of the printing slowing down the DMA handler interrupt? It is, but it also tickled the bug it looks like. So the second time around, we got an ISR. The first channel was disabled. That's what the 4 means. The other channel was enabled, but we actually will disable it later. I don't think it's a new bug. I think this is a race between, like, we check channel mask at the start of buffer filling. But what we really need to do is we need to check it constantly, or every time through the loop, because if we've enabled it but we've missed, I don't know what happens if we trigger a running buffer. I'll have to play more with this on Monday because I'm out of time, but or we'll see if somebody else can fix it. But I think there's a race between, so when we're doing DMA callback function, we grab channels to load mask, and then we load those channels. And I'm actually printing it out here again, which is why we see this. Right, so channels to load mask is originally 8. It gets filled, and then by the time we're done, we're supposed to have loaded the other one. So this needs to be changed a little bit to make it more bulletproof. Like, there's a race between filling the buffer and marking it enabled and getting the trigger to run it. And the filled count 2 is not sufficient enough to get it restarted. So like there's a failure mode where both channels get disabled, right? And that's something around that. All right. Thank you, everybody. This has been a wonderful deep dive. I mean, we touched on a lot of things and got in the weeds like we always do. So thanks a lot, everybody. Have a great next 6 months or so as I go into full-time dad mode. Adafruit.com, support me there. Join the Discord, adafru.it/discord, to chat with me and a lot of other smart folks. And hopefully, I'm super excited to see the Fruit Jam come out. Thanks in advance and always to Tim, who is the other deep diver here. Tim says he's going to try to deep dive regularly while I'm out. And also a preemptive thank you to DCD, who takes time codes when I'm deep diving. So thank you all. Have a great weekend and summer and fall, and I will see you when I have a 1-year-old in daycare. two aspects, 1 year and old in daycare. Otherwise, I'll see you on the Discords. I'll be around. Thanks all.